Good day, everyone. My name is Matthew Ocheleka Itodu. The conjugate base. Then your pH is equals to your pKa. That's to show your pH is your acid and your pKa is your base, your alkaline. We are going ahead. That is to show that the stronger the acid, the tendency to dissociate and to have a dissociation constant. Now, let's represent that equation. All this equation, I want to represent them now. What is the full meaning in a reaction? How do you call this HA? What is your H plus and this your conjugate and this your A negative? Now, this is the meaning of it. Listen carefully. HA is your concentration of the undissociated acid. H positive is equals to concentration of hydrogen ion concentration and A negative is concentration of the conjugate base. So anywhere you see HA, call it concentration of undissociated acid. Anywhere you see H plus is concentration of hydrogen ions, and anywhere you see A negative is concentration of conjugate base. Now I take you back, look at this. Now what I want to do is this. Now we have our Ka as your concentration constant. Now what we are looking for now, we are looking for pH. And then if we are looking for pH, from the earlier definition, we said that what? pH is equals to negative logarithm to base 10 of hydrogen ion concentration. That's the definition of pH means, and this is what your hydrogen ion concentration means. This is what we are looking for. If we accept that this is what we are looking for, now what we want to do now is that what? We are going to do substitution to make sure that what? Your H positive will stand alone. So looking at that, you know already that your Ka is all over 1. Your K is all over 1, while your H plus and your A negative is all over HA. That is it. So that is what I want you to understand from then. And then now that you have understand that, now means to stand alone. Now what are we going to do? What are we going to do? Means we are looking for this. To make this one as the subject formula, we divide both sides by what? A negative and A negative. Now look at it here. Look at it here. Look at it here. Divided by A negative and A negative. KaHA all over A negative. Now looking at it carefully, if A negative cancel A negative, what are we going to have? We are going to have our hydrogen ion concentration to stand alone, which is equal to what? Ka multiplied by Ha all over A negative. Now this is what we have. Remember that definition that say pH is equal to negative logarithm to base 10 of hydrogen ion concentration. That means what are we going to do? What we are going to do now is what? You take a negative log of both sides. That is, you add, taking the negative log of both sides, you add a negative log here, add a negative log to this Ka, add a negative log to this Ha all over A negative. That's what we are about to do now. Taking a negative log of both sides, that is to show that now I introduce a negative log here, I introduce a negative log here, and I introduce a negative log here. But from our definition, we say pH is equal to what? A negative log of hydrogen ion concentration. If we means wherever you see a negative log of hydrogen ion concentration, you put pH. And anywhere you see negative log K, you put pKa. That is the meaning of it. So if we are to substitute just the way I just explained here, means your pH now is equal to what? pKa negative log of what? Hydrogen ion of Ha all over A negative. So now if we have accepted that, now the stronger the acid, the lower it is this pKa. Now we have a negative side here. We have a negative sign here. Now listen carefully now. To remove this negative sign that is here, we invert the last term. This last term. We bring it up and make it as a numerator, while you bring the HA down to become what? As the denominator. Just like the way we normally do in our primary class mathematics, that 1 negative 1 all over 2, if you want to do the sine inverse of it, it will become what? Negative 2 over 1. If what I am saying is correct, that's to show that what? pH is equal to pKa. This negative here will turn to positive. Why? Because this A negative now, that is the denominator, will become the numerator here, all over Ha. Means we have done the sign inverse by removing the down one and bring it to the top. So, and now we can say that our pH is equal to pKa plus log conjugate base all over what? Our weak acid. So when the pH is equal to pKa, the concentration of conjugate base is equal to the concentration of all dissociated acid. Now, listen carefully. This is what we use. We are using HA in equilibrium reaction that release hydrogen ion concentration and the conjugate base to drive pH all over what? pH all over what? pH all over pKa plus log A negative all over HA as what? Our Henderson equation. So we drive our Henderson equation from this chemical reaction. And you can also continue to look at it that you can also look at it in this way that I've already told you that this our HA, this our HA can be carbonic acid, as a proton donor is the one donating that hydrogen ion concentration. And this our A, we call it as the conjugate base as proton acceptors. That's why it's carrying negatives. And then you can also look at it where that the A negative proton acceptors, proton donors, like that. So it's not a big deal. Thank you for listening. If you have any question, forward your question to class and we treat the question accordingly. And if there is anywhere you are confused, you can also come on my YouTube online channel, ask your question, and I will clarify you. Go over this class over and over, and then you understand the process. But in case you may be thinking that all this write-up that I've written to make you to explain this better, if you already understand what I mean in your exam and in your test, you can just go straight and follow all the process to drive the equation of pH, and you still obtain your full mark. Thank you for listening.